Yeah, you are audible perfectly. Perfectly audible, ma'am.
Okay, sir. Thank you. Thank you.
Hello, Hari. It's already 5. Hello.
Hello, sir.
Okay, Sonu.
So, good evening,
Hi.
everyone. Good evening, everyone. As a humble beginning towards empowerment of a society through technology to create a better tomorrow, the IEEE Society of SP presents you EV Era, a talk on role of electrical engineers in electrical vehicle era. With great pleasure, I would like to extend a warm welcome to everyone present here. Welcome all. We're extremely delighted to have with us Dr. K. Deepa as a research person currently serving as the assistant professor at the Department of Electrical and Electronics, Amrita School of Engineering, Bengaluru. She is a senior member of IEEE, being the IEEE PELS Secretary, Bengaluru section, the advisor for the IEEE PS and IA student branch joint chapter, and advisor for the IEEE in Amrita School of Engineering, Bengaluru, and life member of IET and IST. Welcome, ma'am. Now
Thank
I'd
you.
like to welcome. Okay, ma'am. Now I would like to welcome Salan Sir, RPS SPC advisor, to deliver the official welcome address. Sir, please.
Okay, so good evening, dear all. Without making any delay, uh, so hope all are vigilant when you go out from home in this COVID time. Let us hope Almighty may stop this pandemic soon. And now to the topic already Lakshmi told some glimpse of our resource person. We're very happy to have with us Dr. K. Deepa and about electric vehicles. It is one of the most astonishing moments for electrical engineers trying to overlap on mechanical engineers. That is trying to replace IC engines in transport road facility around the world. So it is actually one of the most sought after research oriented section in electrical engineering branch. So I would like to say some points uh, for regarding our today's resource person. She is currently working as assistant professor at Department of Electrical and Electronics, Amrita School of Engineering, Bengaluru, and she has more than 23 years of experience in teaching and has around 40 plus international journal papers and already written 2 books, Control System and Electrical Machines. Okay. And regarding her education, took her BE from Alagappa Chettiar College of Engineering and Technology, Madurai Kamaraj University in the year 1998 and took her M.Tech in area in power electronics from Jawaharlal Nehru Technological University, Anandapur, that is in Andhra Pradesh, and from the same institution took her PhD. So this is actually a small glimpse on the details of our resource person. So we are very happy and privileged to have ma'am with us. So on behalf of College of Engineering Attingal and all the participants, I heartily welcome Deepa ma'am to this session, and I hope that this will give a lot of glimpses for all of us on the latest EV tech. And all the best to Deepa ma'am, and that's it. Okay.
Thank you, sir. Before we get started, I would like to remind you that please ensure to mute yourself during the entire session and will be provided time for questions at the end so that you can ask and clear your doubts. Either you could type your questions in the chat box or else please feel free to unmute and convey yourself. Now, without further ado, over to you, ma'am.
Thank you. Thank you, Lakshmi. Am I audible?
Yeah,
Yes,
ma'am.
ma'am.
Yeah, ma'am. Yeah.
Yeah. Thank you. Thank you so much. Very happy 75th Independence Day. And it's a great privilege for me to deliver a talk on electric vehicle on especially this special occasion on 75th Independence Day. So I thank College of Engineering Attingal and especially Sri Hari for contacting IEEE Student Activity Committee Virtual Speakers Bureau for arranging this particular webinar. A special thanks to IEEE HOD, Mr. Shalin, for having arranging this particular webinar. Students of electrical, I guess the students are all from electrical background. So today's era and the remaining 20 years from now would be an electrical era. We all know that already electric vehicles have taken a long way. It has already started off. Now, as an electrical engineer, what is that we are going to be and what exactly is electric vehicle about? So where are our concepts going to be employed and what is going to be the concepts of electrical engineering linked with electric vehicle, or what is going to be our future in the next 20 years? So this would be the total glimpse of the titles, whatever I'm going to just stick upon for the next 45 minutes. So before we go into any topic, we should be aware of what exactly is the present situation and why it is needed. Why is government talking about electric vehicle fleet? So there comes the greenhouse effect. So to just have a small idea, this particular image is from the net. So for each and every slide, I have given the sources. The link for that particular image is also, so that it's easy for you to, so that you can go back and repent on these topics. So from the sunlight, the solar radiation reaches the earth. When before it reaches, it gets reflected at different areas. Okay, stratosphere, ionosphere, and then it reaches the earth. When it reaches the earth, it is being partly absorbed, and the part of it is being radiated outside from the earth to the space. When it is radiated, it is being absorbed. Some of it is being absorbed by greenhouse gases. So we will see what are these greenhouse gases. So these greenhouse gases is mainly in the atmosphere, which keeps our earth warm, so that sustainability is there. Sustainability of life is there. So this particular thing is a normal phenomenon, which is not hazardous for us. So, but due to our human activities like burning fossil fuels or agriculture, burning of agriculture or land clearing, etc., greenhouse gases are being released. Those are a little bit hazardous. Okay, so these greenhouse gases tap more energy, more heat energy, which is more than the sufficient level what is required. So this heats up the atmosphere, and this heating affects in cooling off the icebergs over there, and so the sea level has increased a lot, and this has affected our total ecosystem. So greenhouse gas is, the whole process has been given over here in this slide and the previous slide. And we could see over here, carbon dioxide is the major shareholder of this particular greenhouse gases. Okay, so these are the list of greenhouse gases which are available, and I've just given the sources also. So the normal human activities gives out many of these greenhouse gases, and letting out of these greenhouse gases now increases the temperature, global temperature. So that is the concern which is for the last 10 years. Now, due to COVID, as Zalan sir has already told about COVID and the precautions what we are already taken up, this COVID has made us fully online. So we have tapped out all the resources online, and due to lockdowns, first lockdown, second lockdown, or triple lockdown in Kerala, all these things have reduced the amount of oil usage in India. Oil usage in the sense the transportation sector has not been utilized to the fullest. So you see over here, there is a small dip in the CO2 emission. The whole graph, this is just to give you an idea of the feel of why we should go to EV. Okay, so this particular graph shows you the CO2 emissions from the global energy perspective from 1990 to 2020. You could see a dip over here, and this dip is during the COVID season. The emissions have fell around 1% during this particular fiscal year of March 2020. And you can see over here, it has gone negative. In 2020, the total consumption of coal, oil, and gas have gone negative, totally negative. It's all because of COVID. But this gives us a vision that the total carbon dioxide emission is mainly because of the transportation sector, because transportation sector plays a major role in this CO2 emission, which is nothing but the major contributor for greenhouse gas, and that increases the temperature, which in turn increases sea level, etc. So this is going to be a cyclic process. So this overall picture here gives us the yellow color line, whatever is shown here is India. Okay, you can just see that there is a dip in April, which was the first lockdown. During the first lockdown period, the transportation sector saw a full dip over there because there was no transport at all because it was fully lockdown. And then we have released the lockdown. In India, the transportation sector is increasing. The road transport is increasing. And the same thing could be seen for aviation. Aviation is still not used fully. We have just stopped aviation for abroad things, so it is a little bit lesser. So these things are being seen in COVID because of lockdown. So if this situation is prevailed, that means if the usage of fossil fuels and the oil is being decreased, then the greenhouse gas effect could be reduced, and we could save many billions from the oil imports. Okay, so this could be one more thing which could give us the usage of coal from 2010 to 2020. Okay, so this is renewables. You can just see over here, it is just increasing for renewables. Renewables have been increased and the usage of coal has been decreased. So this is the whole global electricity generation. So this tells us that we are moving on to we ourselves moving on to renewables, cutting down our IC engines and moving on to electric vehicles would definitely help us in air pollution, which help us in all the environmental aspects, etc. And in extra to that, our GDP also would increase because we are not dependent on the oil for transportation. So this particular slide gives you 1 year full view for CO2 emission from 2020 for last year with respect to 2019. You could see that it is totally negative. The CO2 emission is totally negative, and in December it has started to go positive. That means it's totally negative with respect to 2019. What exactly are we trying to do? That IC engines are on the road were very, very less. So if we are going to replace the whole IC engines by electric vehicle, the same graph could prevail in future also. So that is the full idea behind showing off these statistics. So this is the overall thing which is for different countries being shown over here. You can see over there for India, it is increased now in the late of 2020. It has increased. Okay, so previously this increase is indirectly telling that we have come out of the late of last year. We didn't have much of COVID restrictions. We had restrictions on the first lockdown during the March-April period. Okay, so this reflects our CO2 emissions also. Now, having talked about all these things, our IC engines are the best person for air pollution, the one and only contributor for air pollution. So we are trying to find out an alternate. So before we find out the alternate, what exactly has been evolved is being given in this particular slide. So the first conventional vehicle was having the fuel with engine, that means the IC engine, which was used for the transportation for any electric vehicle. Electric vehicle, when we are talking about, it doesn't mean that it is an electric car alone. It starts from a two-wheeler, auto rickshaw, going to a truck and heavy bread truck also. All these are electrified. Even the metro has been electrified. We have the fully electrified ships. So all the whole of transportation sector is now being electrified. So this is altogether being shown, but just for your understanding, I have just taken a car. So a conventional car is replaced with hybrid. That means a part of the supply is being taken from a battery, which takes out the major part of the movement, but a little part of it is being taken out of the battery with a motor generator set, so that the regenerative energy charges the battery. But People were finding out still they went in for fully electric vehicle. So it's fully being powered with battery. With the special machines coming into picture, we had many special machines, and the control techniques have gone a wide range, a higher range. So these control techniques and the inventions in batteries, the battery technologies inventions, the motor special electric machines coming into picture have made this battery electric vehicle possible. So the whole of motor concept and generator is being the working of motor is being taken care only with the battery system. So that this is how a battery electric vehicle has come into existence. Now, when you're talking about electric vehicle, we have already seen this hybrid car. That means you have a petrol or a diesel oil to be filled in, and a small part of it is taken by the battery system. Okay, and the other one is going to be the internal combustion engine, which is mainly dependent on the oil. And you can just see that indication, the air pollution emission is more over here. It is little bit lesser, but still you have a considerable amount. So we are moving on. This green color tells that it is electric. We are go green. Okay. So this is partly electric, partly it is combustion. It is combustion in nature. This is called as plug-in electric vehicle. You can plug in your battery anywhere, wherever you want for recharging your battery. So, but still, this also have not solved the purpose. So we have gone fully electric, which is go green plant. So this has no emissions at all. As you all know, we don't have any emissions in our motoring system. So this is the different types of vehicles which are available. Your internal IC engine, which was the first initial thing, which then changed in for hybrid, and then people went in for plug-in hybrid because these batteries were not rechargeable batteries. The hybrid vehicles, the batteries, whatever is used were not rechargeable batteries, and then so people went in for plug-in electric vehicle. Similarly, the battery industry, researchers in battery industries are also aided for the decrease in size of the battery with a higher specific energy and lesser weight. So this has gone for electric vehicle. So why electric vehicle? We have already talked about this in the previous slide. Why do we go in for electric vehicle? This, of course, decreases the total air pollution totally, and we are no way now dependent on to the fossil fuel or coal or nuclear, provided these batteries are being charged from a renewable source. Maybe it's from a solar or from a wind powered charging station. If these batteries are being charged, then we are totally not dependent on the grid system or on the fossil fuels or on coal or nuclear or the steam turbine or the grid system, which is normally with the conventional systems. So these things would now push India to the mission of India, which is go green. So this is why we are going in for electric vehicles. Out of the 30 most populated cities in India, India stands 21st, and the transportation industry is contributing about 14% for the total air pollution. And this is due to the increase in the individual, each and every individual having a vehicle and the traffic congestion, etc. So electric vehicle is the one and only option for changing out, because the top speed characteristics of an electric motor is similar to that of an IC engine. So the only replacement of an IC engine could be an electric motor. So here came the full electric vehicle. This slide gives you an overview of how electric vehicle where it has started and where we are today. It first started off in 1914, and then you could see that there is a very, very less improvement in electric vehicle, because that time it was totally DC, and we are into AC system. So it was very difficult for conversion, and power electronics were not into picture. So AC-DC conversion or storing of that particular energy and controlling was very big problem. And of course, the IC engine market was on the top. So it has not allowed electric vehicle industry to come up. So the improvisation or the researches in electric vehicle was less, but still there were researches going on, which is being shown by any kilowatt vehicle or Electroware or Enfield 8000, all those things. But the recent years from 2010, you could just see that the change, whatever is happening, is name any automobile company, OEMs or original equipment manufacturers. Name any OEMs, they do have an electric vehicle as on date. So this era is now electrified totally. So what exactly is electric vehicle? We as electrical engineers, now coming on to the topic, what exactly I have to talk about the role of electrical engineers. Any electrical engineer would be targeting on to his machines topics. Maybe you would have had DC machines or AC machines. And then to control these machines for the speed control characteristics, etc., we would have a subject which is power electronics into picture. So power electronics, you would have studied about rectifiers. So a rectifier is a unit which converts AC to DC, or an inverter which converts DC to AC. So both, when you have AC and you wanted to convert it to DC, you go in for a rectifier. The reverse is being done with a inverter. Or if you have V by F control of an induction motor, you have an induction motor and you wanted to go in for speed control of it, we go in for V by F control. Both voltage and frequency has to be changed. So we go in for the concepts of cycloconverter or AC voltage regulator, etc. So power electronics have been pulled into electric vehicle. So as a power electronic, you can do wonders over here. And then coming to your batteries, battery is going to be the one and only source of energy in an electric vehicle. So this particular energy has to be delivered to the motor at a constant rate, and it should be managed also. So controllers comes into picture. Name any controller. Name it is going to be a microcontroller or Xilinx or any other controllers which you have studied. Microcontroller would have been basic subject, one subject which you would have studied. So that comes into picture for controlling the motor as well as the battery unit over here. So these are the major subjects of electrical engineering coming into picture for electric vehicle. Now, the next 15 years or 20 years is going to be EV. EV is going to take it up to the maximum. Even in this COVID situation, you could see that many of the companies releasing their electric vehicles, and the released electric vehicles are totally being brought out the next day itself. So that is the state of electric vehicle for present day. So what are the main components of electric vehicle? The main and foremost thing for movement is going to be with the traction motor. So this particular unit is your traction motor. So you have to have a controller for it, and this particular motor has to move it, or it should need power. So an electric motor is a device which takes in electrical energy and converts into mechanical. So electrical energy, where does this electrical energy comes from? So that is from the traction battery which is being placed. Just imagine the whole deck of the car is being placed with batteries. So that much amount of battery is needed for the movement of the car. So the whole deck of the car is being replaced with batteries. The whole system is battery. So this is your traction battery, which is of course DC in nature. So this DC, if it is directly needed, if it is going to be a DC motor, it could be directly being supplied, or if it is going to be an AC motor, it has to be inverted. This is DC and it has to be inverted so that it converts the DC to AC and then gives it to the motor. So there is a controller and an inverter module over here. So this module is the controller and the inverter module which converts DC to AC and feeds into the motor over here. So this DC, when you're directly giving DC, you all know that you should have some control over there on the motor, because as you're talking about an IC engine, you might be having 4 gears. Okay, similarly here, instead of that, I would be having different speeds over here. I don't talk about gear system over here. Instead, I just have a different variable speeds. So how do I get that variable speed? So the variable speed has to be got with only voltage adjustment. So for that voltage adjustment or any other small changes, we need a DC-DC converter, which is again power electronics coming into picture. When we all know, when we are working out with motors, of course, a lot of heat is being generated because you have heavy current going over there, because the load involved is here more. So when the load current is more, your I squared R losses are more. When your I squared R losses are more, obviously heat produced is going to be more. This might disturb the whole system, or it might lead to some fire hazard. So we needed a thermal system over here, thermal cooling system. So we have a small thermal cooling system which cools the entire deck. In extra to this particular main movement, we have many auxiliary units. What could be those auxiliary units? It could be a wiper system, or it could be the AC, or it could be the dashboard system, which are being powered with very less voltage. Need not be 72 volts, etc., but it could be from 12 volt system or a 48 volt system. So you have a small battery backup, which is the auxiliary battery backup, which is this voltage, which is of very high voltage. Okay, it could be 380 volts or it could be 78 volt, depending on to either it is four-wheeler or two-wheeler. That is being stepped down. That is being stepped down by a DC-DC converter. Okay, and that step down is voltage is being charged, is being stored in a small battery, which is called an auxiliary battery, which takes care about all the extra auxiliary units in a car. And then you have a charger unit. So when this particular battery is discharged, now it has to be recharged. So similar to the petrol or the diesel tank, you have a charging unit over here, which is connected to the charger. Okay, and this connecting unit is now connected to an onboard charger. What exactly is an onboard charger? It's again a power electronic device. Okay, now it has an AC to DC converter, or normally it could be a bidirectional converter. It could do either AC to DC or DC to AC also. So you have a small onboard charger also, is depending on to the charging. We will just see that in detail because we have different types of charging units. So we'll just see that also. So these are the major subdivisions or the important parts of an electric vehicle. Now this would give you the same meaning of the previous slide, but in an easier form. So we have the AC grid. All the supply, whatever we are getting is AC. Okay, so but the battery, whatever we have, should be charged in DC. So we have an AC to DC converter rectifier. Okay, so it is being rectified. AC is being rectified, which is done in your onboard charger unit. In the previous thing, we have seen a small box-like structure which tells that it is an onboard charger. What exactly is inside an onboard charger? You have a rectifier unit which converts AC to DC, and this DC would have some fluctuations. Okay, and if you wanted this particular DC or the battery, if you want to charge it at a constant voltage or constant current, or you have to go in for trickle charge or floating charge, then there should be a control brought into picture. So that is being done with an isolated DC-DC converter. DC to DC converter, maybe this voltage is going to be 520 volts or 480 volts, etc. So that is being converted to a different level which the battery requires at a constant value, and it is isolated because this particular is going to be a three-phase supply which would be very high voltage, and so we wanted to isolate the car and the actual system just for safety purpose. So we have introduced an isolated DC-DC converter over here, so that an isolation has brought into picture with automatic with your power electronic device. So this AC-DC rectifier and the isolated DC-DC converter altogether now is called the onboard charger. Now we have the high voltage battery which is being charged. For example, this is going to give you about 400 volts. The total voltage of this particular battery is about 400 volts. And this is going to feed the supply to the electric motor, whatever is there taken up for that particular electric vehicle. So that electric motor could be AC in nature, so you needed a DC to AC inverter over here. So this is the mainstream, which is the major cause for the electric vehicle movement. But you do have an auxiliary system, as I told you before. So we have this particular 400 volts has to be converted to a low voltage, which is 12 volts, and has to be stored in a battery. So again, an isolated DC-DC converter is being used. Why isolation? Because this is 400 and this is 12. So hence there is a need for an isolation, which is inbuilt in an isolated DC-DC converter. So this is 400 volts is being stepped down to 12 volts, and that is being stored in the auxiliary battery. This particular 12 volt battery now takes care of all the electrical loads, which are maybe it could be an it could be the wiper movement or the dashboard equipment, just telling us what is the SOC, what is the SOC of the battery, how much time is remaining, or etc. Those things, or it could be the AC system or the speaker set. So those particular things could be powered by a 12 volt battery system. Either this particular 12 volt can be directly taken by the non-propulsion electric load of 12 volts, or if it is going to be a small controller units, it needs only 3.3 volts and 5 volts. So again, you have a small DC-DC converter which steps down 12 volts to 3.3 volts or 5 volts. So this is the overall architecture of a battery. And for further reference, you can just refer the recent IEEE's magazine, Electrification magazine, which was in June 2020, where extraordinary explanation for the same is being given out. So now the role of electrical engineers. Having seen what are the different parts of an electric vehicle and what are the different subjects have been involved, now as an electrical engineer, we are here to design, develop, and test these following things. First and foremost, the source of the system. This is nothing but energy storage system, the whole battery. And next is all the power converters. We had seen AC to DC, which is rectifier, DC to AC, which is inverter, and then we have seen all the DC-DC converters. It could be isolated or it could be non-isolated also. So all those power electronic control converters has to be designed, developed, and tested. Next, moving on to the motor, all the drive system, the total drive system, drive train has to be designed and it has to be controlled. So that particular part comes in your machines and drives. Next comes the electronic components and the other system vehicles, or the controller, braking system controllers, and the braking system for your safety, your airbags or your anti-locking system, the starters for the motors, initial starting current, you know how much it would be. So what would be the safety measures you're going to do for it, or your radio and infotainment systems, or electric lock, window systems, and windshield wipers, electronic actuators, etc. Now, when all these are going to be electric, autonomous vehicles are now in your future. When everything is going to be electric, it's going to be controlled smoothly, and this could be done through an IoT system also. So that now leads you to the autonomous vehicle. So in your future, we might think about autonomous vehicles moving on in the roads of India. Now, this is the overall. I have given you an overall picture of the electric vehicle. Now these are the individual things for your understanding. How exactly would it look like? This is the traction battery system, which is that 400 volt battery system, which is being shown in the previous slides. So this is how it would look like, which is being placed at the deck of the car. This is how it would look. The deck of the car is fully arranged with batteries. And these batteries, of course, would be again the basics of electric circuits coming into picture, or your basic electricals. Depending on the voltage and the current rating, these batteries are connected in series and parallel. Okay, so these all together, this particular thing is the total battery system for an electric vehicle. This is an inverter set, which now converts the DC output, which the DC input, which is being got from the battery, and converts into AC, which is being fed for the motor. There is one small thing which has to be brought into picture. You all will be knowing that in electric motor, regeneration is possible. What exactly is a regenerative braking? You all would have known that we would have used a reverse gear for going back, or when we are applying a brake. It is like the vehicle was in movement, so you have some kinetic energy which was already there when the vehicle is in movement. Half mv squared is going to be your kinetic energy. So the mass of the vehicle is there and it is at some velocity moving. So this particular kinetic energy, when it is all of a sudden stopped, the vehicle is coming to when a brake is being applied, or either it could be a sudden brake or an ordinary brake, depending on to the traffic conditions of the Indian roads. So when they are applying a brake, that particular kinetic energy now is being transformed as heat and is being dissipated onto the tires over there. But in electric vehicle, this particular regenerative braking comes into picture. This kinetic energy now is being converted as electrical energy, and it could be used as this particular electrical energy can be stored in the battery system. So how could this be stored in a battery system? If this AC is being converted to DC, then it could be used for storing in the battery system. So an inverter, whatever we are talking about, is bidirectional. What exactly is bidirectional? So I would just move ahead over here. So the inverter, whatever we are talking about here, is bidirectional in nature. So bidirectional in the sense it has a forward direction working and it has a reverse direction working also. In the forward working, it takes the voltage from the high voltage battery, 400 volts, and it converts to AC and feeds into the motor. In the reverse, during regeneration, the particular kinetic energy from the motor is AC in nature, which is being converted to DC. Okay, this inverter now does the reverse operation, which works as a rectifier. How can this work? It is all with switches. Inverter is a device which has 6 switches. So this 6 switches, if it is bidirectional in nature, then you can control the reverse flow of energy also. So this inverter is now made to work as a rectifier, and the kinetic energy is now being converted to electrical energy, and that is being stored in the battery system. So we are now recharging the battery, so your mileage might increase. And one more thing is, in the IC engines, that particular thing is being, the whole energy is being dissipated as heat, whereas here we are converting that as electrical energy, and we are recycling that particular energy. So it's a little bit efficient when compared to your IC engine in the other aspect also. So that is what is about inverter. Inverter, whatever we are talking about, is now here seen as a bidirectional inverter. In the forward direction, it is an inverter, and in the reverse direction, it works as a rectifier. Next, the controllers. Anything, any switches, any power electronic devices which we are bringing in should definitely have a controller. So here, this controller now regulates the energy from the battery and the inverter as well as the electric motor, so that the power which is fed to the motor is now adjusted, so that the speed is adjusted, or your braking system, when the power is being braked, or when the car is, when you have applied brake in the car, then automatically the power to the motor is being stopped. So all these are being taken care by your controller unit. So of course, if it is going to be an induction motor, I have already told you that the speed control of an induction motor is with your voltage V by F control. So your voltage also has to be varied, and your frequency also has to be varied. So those things have been now taken care with your controller part of it. Accordingly, the controller gives the instruction to the switches of the inverter. Moving on to the electric motors. Initially, we had only DC motors. Since it's a battery system, we were thinking only about the DC motors. DC motors are of shunt and series type. Series, we know that series have many disadvantages. Shunt motor is going to have a constant speed motor. It's a constant speed motor. We cannot increase the speed over there. And when the load increases, then the speed dips out in the shunt motor. Whereas in a series motor, it could take more amount of load, but the control of a series motor is a biggest complex task. So hence, people were not comfortable with these two motors. Hence, the research in that electric field was being dipped in the initial starting era. Now, DC motors have been taken up by AC motors. AC motors in the sense induction motor. Again, induction motor also is now replaced by your special electric machine, which is your BLDC motor or a PMSM motor, permanent magnet synchronous motor, etc., or a BLDC motors are now being replaced. So the researchers in your machines or your motoring sector, which is your special electric machine, have also aided your electric vehicle or transportation sector. So these are the different types of motors which are available: BLDC motor, brushed motor, permanent magnet synchronous motor, induction motor, switch reluctance motor, etc. Mostly BLDC motors are being preferred. And this slide would give you the comparative study of a DC motor, induction motor, a permanent magnet DC synchronous motor, or a switch reluctance motor. Okay, so as you could see over here, your DC machine, the cost is more, induction machine cost is more, whereas your special electric machine, you can just see the cost is more. And similarly, it could give you the equivalent performance as that of an AC machine. Okay, equivalent performance can be got. Power density is more, efficiency is more, controllability, reliability, and technological maturity is a little bit equivalent to your induction motor. Next, as all these things are going to be mechanical in nature, you needed a transmission system which transfers the mechanical power from the electrical motor to the drive system. So you have, this is your transmission system, what is being used. Now, the whole battery which is being placed on the deck, when it is being discharged, then you need a charging system. So this is a rechargeable battery. So a charging system is required, because you cannot charge the battery at your own rate. So a constant voltage or a constant current, or you call something as flow charging at the last part of the charging, or you may want to maintain the overall voltage which is by your trickle charging. So these type of things has to be taken care. So a charger is must for any battery system to be recharged. So we have two different types of charger. One is the onboard charger, the other is offboard charger. Every electric vehicle comes with a small unit which is an onboard charger. okay, which is inside the car. So we can't load this particular car because the weight of the car is more important, because as the weight of the car increases, the tire's body of the car increases, then the vehicle movement would be very difficult. It will be very difficult for movement. The speed of the vehicle will come down, or it has to give in more amount of energy for the movement. So each and every part which is being selected for an electric vehicle has to be thought of from the weight point of view also. Hence, the onboard charger is very small in structure. It's lesser weight, so that it could convert only little part of it, little bit. It can take care of little bit conversion. So that is about onboard charger. Hence, only since little bit conversion is being taken care, we are supposed to have an offboard charger. We will see that in detail in the remaining slides. So you have an auxiliary battery system which takes care of the 12 volt supply, or it could be stepped down to give the 3.3 volts or 5 volt supply. And this is being charged from your high voltage battery itself. DC converters, which are used for stepping down the voltage and charging the auxiliary battery, or for maintaining the voltage for a charger. So it could, from a high voltage, it could be stepped down to a lower voltage where you are using a buck converter. A buck converter is a converter which steps down voltage from 400 volts, it steps down the voltage to 12 volts, and it charges the auxiliary battery system. This is your thermal cooling system. As we have already seen that when we are discharging and when the motor is in operation, the current drawn the motor is going to be high. I squared R comes into picture. So to remove out the heat, we have a thermal cooling system which is readily available. This is the look of a charging port. We would have seen that in a petrol or a diesel engine, it's just a hole over there where your petrol or diesel is just been poured, and you just see what is going to be the amount of liters of petrol or diesel is going to go in. But in electric system, it's going to be totally different. First of all, when the charger is being brought into the charging port, first and foremost, we'll have to check in for the continuity of the supply, whether it is being connected properly. If it is not connected properly, there is an open circuit over there. There might be a possibility of arcing, or it could land out when your shock issues. Okay, some safety hazards would be there. So the first and foremost is connectivity between the vehicle and the charging station is must. Once when it is being connected properly, then there is a communication between the vehicle and the charging station happening, because that particular communication, it tells in the charging station what is the current state of charge of the battery. SOC, we call that as SOC. Of course, you guys would have come across this word SOC, state of charge. In your IC engine, it would be the level of the petrol what is available in your vehicle. Maybe in the fuel tank would tell you how much amount of petrol is available, whether it is reserved or it is just above reserve, or etc. So similar to that, it tells you the exact state of charge, what is the total amount of energy which is available in the battery system. So that particular thing has to go to the charging station, and then you will instruct the charging station how much you wanted to charge. Okay, so those things have been done with protocols. Okay, there is CAN protocol, standard protocol, which is readily available. So for all these things, communications and for safety units, we have a special structure which is being given over here. So this is the look of the charging port, which is being taken care by the total controller unit. So we have seen altogether what is an electric vehicle, what is the need for an electric vehicle, and now we have come to the main part of it, which is nothing but batteries. The first and foremost thing which has led for electric vehicle is the battery system. So once when the battery system still researches are going on, so in near future, you might go in for a reduced weight of batteries, smaller size battery with high specific energy. So these are the different batteries which are readily available, out of which lithium-ion battery is being used for an electric vehicle. We would just see a glimpse of the different battery chemistry. So I've just given a glimpse over here. First and the foremost was lead acid battery, which was used before. These are one of the oldest rechargeable batteries. They're rugged, but on usable over a large temperature range, but they have very low specific energy. So this cannot be used as a replacement for, it can be used as a substitute, but it cannot be used as for an electric vehicle, because the specific energy is very less. So it cannot sustain energy for a longer duration. You would not get mileage for this particular vehicle with lead acid. So lead acid is not being preferred. So it could is just preferred in a golf cart, or in UPS you will be seeing a lead acid system, or wheelchairs or vehicles or boats, small vehicles and boats, you'll be seeing a lead acid system. Now, next is a nickel metal hydride. So coming out to the difference between a lead acid with your a nickel metal hydride. Both have matured battery chemistries. Both are obsolete. Of course, what we are going to use is going to be lithium ion, but we are just seeing how this particular battery technologies have evolved. Okay, the lead acid battery are used in the conventional petrol driven vehicles and are inexpensive, but the specific energy is very less. As I told you before, it could not be used for a longer mileage. Its specific energy is just 34 watt per kg. But in nickel metal, it is going to be 68. So when compared to lead acid, nickel metal has a better specific energy. So mileage is a little bit better when nickel metal hydride is being used. So what are the advantages and disadvantages of nickel metal hydride? It is lighter and reduced energy cost and greater energy density, of course, twice that of lead acid. Okay, and occupies less space. But it is having more of self-discharge. What exactly is self-discharge? You people have heard, or you would have definitely used a car, because you would have got your license now. So you would have drive the car also. During your COVID period, you would have not taken the car for a longer duration. So immediately one of your family member would have told you to just go weekly once to start the car and just keep it on for some time, so that your battery doesn't go down or it doesn't become a dry cell. What exactly is happening? Though you are not using it, though it is not being used up, your battery drains off. That is called as self-discharge. So the self-discharge in a nickel metal hydride is very high. It is up to 12.5% per day at nominal room temperature itself. Okay, so and it is not being suited for hot environments. So hence we go in for lithium ion batteries. It has an excellent specific energy, 140. Just imagine, it is when compared to your lead acid, it was just approximated to 40 watt hour per kg. This is 140. Self discharge rate is also very less. It is just 5% per month. The previous nickel metal was 1.2. Previous thing was 12.5 per day, but this is 5% per month. So comparatively, your nickel ion has come up. But this is an expensive battery technology, so we have to be very careful when you are charging. It should not be overcharged or it should not be overheated. So that those two things has to be taken care, and we are using lithium ion batteries. Now, having told about battery, now we have selected the battery. Now it's going to be lithium ion. Now, moving on further. Now, this lithium ion has been replaced by the other technologies also. This is just a glimpse. Researches in that particular field is going on in 10-fold times. So it is replaced by a newer technologies each and every day. So this is one of the place where much scope is being expected. Battery chemistry and battery technology is the one which is going to change the whole era. Electrical vehicle era is more dependent on the battery technologies. So what are the factors which are influencing this capacity? The rate at which you are charging and discharging, okay? The temperature at which the cell is being present, self-discharge rate. Even though vehicle is not being on use, it is having a self-discharge rate. How many cycles? Because when you get a battery, there might be 2000 cycles. That means one full discharge is one cycle. 100% discharge is being counted as one cycle. So totally it can go up to 2000 cycles only means. So you can use only the battery only for 2000 cycles. So the cycle number is more important, and you should not overcharge also. This might affect the whole battery system. So the next important thing what we have to come to know is battery management system. So there must be one unit which monitors all these things, whether it is being overcharged, how many cycles have gone in, what is the current state of charge of the battery, what is the rate I have to charge, what is the total number of cycles, etc. So there comes the battery management system. So BESS is battery energy storage unit, or it could be ultra capacitor also. Okay, so you have a bidirectional DC-DC converter. Why is it bidirectional DC-DC converter? First is it has to discharge. Okay, so this particular battery has to come to the common bus system. So you have to boost the energy. Maybe this is 48, and I have to boost it to 72 volts. So 48 to 72, just for an example. Okay, I'm boosting the system. Whereas when I am charging this particular battery, I have to step down the voltage from 72 to this DC bus, let it be 72. Okay, 72 has to be stepped down to 40. So I need a buck system. So this is going to be a buck boost converter, a general, just for a general explanation. Okay, so this is a bidirectional DC converter, and you have a controller for controlling the switching action of this BMS. The battery management system should take care of the self-discharging capacity also. Okay, so that particular thing would be taken care by the voltage sensor and the temperature sensor. But each and every battery would be having a temperature sensor and a voltage sensor. Say suppose if these two cells are being connected in parallel and both are rated for 3.3 volts. Okay, and if one of the cell is reading 3.3 volts and the other is reading 3 volts, then the whole battery pack would be affected. Even this 0.3 volts, just imagine the battery pack is going to have thousands and thousands of cells connected in series and parallel. So even if one cell in that particular series combination is going to have a lesser voltage, then the whole voltage system is being affected. Okay, so to balance that particular thing, why is this particular imbalance is coming into picture? It is because of self-discharge. Okay, some cells would be older, or some due to heat they would have lost their resistive properties. So the voltage it will discharge faster and it will charge faster also. Both will happen at a faster rate. The cell which is faulty would be charging faster and will be discharging faster than the other cells. So this would totally erupt the whole system. So we should monitor these things, which is being done with your battery management system, with your voltage sensor and your temperature sensor. Now, to have a better understanding, this particular thing would tell you why is cell balancing required. Say, for example, I'm just having a battery pack which is having 5 cells which are connected in series. Okay, and each and every one single battery or the cell, what I'm talking about, is not of same SOC. SOC is nothing but state of charge. This cell is having 70% of charge. That means you have 70% of energy still remaining. Here it is 80%. Here it is 50%, 60 and 50%. All together, they are not same. The average of this is going to be 62%. Okay, so why is this particular change is happening? Why is this 30% left out, this 20% is discharged and this 50% is discharged? It is because of the self-discharge capacity. Okay, this cell is totally old now. These two cells, which is 50%, is totally old. It will discharge faster and it will charge faster. So that will be a thing which has to be noted down in future. This will erupt the whole system. The next example is, if you could just see over here, this is at minus 10. The same 50% is now at minus 10, minus 10. That means, what does that mean? There is no energy at all. Normally, you would have heard about when you're using any battery, we don't allow that to drain it fully, because it becomes a dry cell. A dry cell, when you're draining it fully, it reduces the lifetime of that particular battery. And when it's a dry cell, the amount of time taken for recharging it is going to be higher. So we don't allow any of the battery to go for dry cell region. So hence we always operate the battery from 20 to 90% SOC range. Okay, we don't go below 20%. Normally they tell the range of 30 also. The 30 to 20% is the minimum value which you try to operate a battery. Below that you don't go. You just have an automatic cutoff that the battery is being cut off from the supply, as supplied. So this is one more example where this is overcharged. This one cell is being overcharged. These two cells are overcharged. This also would affect the system. So what is the reason for all these things? And whatever is shown over here, 98% is the average of all these things. Okay, average of 100, 110, 80, 90, and 110 out for five battery cells. So this is going to be the total SOC of the battery pack. But individual batteries, a cell is having a different SOC. This is not healthy atmosphere, or this environment might be hazardous for the whole battery system. And hence we have to have cell balancing. I should have totally either 80% or totally it should be 60%. So what should I do? I have to go for your basic techniques from electrical, so that I manage a same voltage. Either I discharge this particular cell alone and bring it to a nominal voltage as 50. I discharge 30% here, I discharge 20% here, and I discharge 10% here. Okay, each and every individual cell, if I connect it to a resistor, just imagine I'm connecting a small resistor to each and every cell over here. Then in that resistor, I'm dissipating the energy so that 30% SOC comes down, here 20% comes down, and here 10% comes down. Then we are maintaining everything at 50. But is it a healthier mechanism? No, not of course, because we are dissipating the energy and we are wasting the energy as heat. So that is not a healthy atmosphere, but still that is being opted in conventional systems of electric vehicle now, because battery life is more important. So that has been opted. Next, people have gone for different technologies also, that we would see it in the remaining cell. So this is also one of the example for the previous thing. It's just a repetition of the previous thing. You can see over there, all the other cells are equally charged, whereas these two cells alone are being charged to the extreme 100%. Okay, these two are defective, so it has charged faster. Same, similarly, when you're discharging also, there is a 10-30% of the charge remaining, but this has been totally dried up. Okay, so because these two self-discharge rate is very high, so it is charged and discharged faster. So this has to be taken care while we are charging and discharging also. So there comes the importance of cell balancing. So we have two different types of cell balancing, which is passive and active. So I've already told about passive cell balancing. And active in the sense we have the switch involved. Okay, passive balancing is a resistor. Each and every cell is being connected to a resistor, and whichever cell is having the higher SOC is being discharged. That cell alone which is being connected, and it is discharged through the resistor. And people have gone in for, since energy is being dissipated there, people have gone in for storing that particular energy in the capacitor and then giving it back to the lower cell. Maybe suppose if I have the cell 1 of higher SOC, then this capacitor is being connected through S1 and S2 over here. Okay, so the cell is connected through S1 to the capacitor and back to cell 1. What happened? The extra energy from this cell is being transferred to the capacitor. After energy transfer, this capacitor is connected to the dotted lines. You can just imagine C2, cell 2, through the dotted line, this charged capacitor is connected back to cell 2. That means this extra energy is being transferred to the capacitor. Now this capacitor transfers the energy to the cell 2. So this is also one way of battery balancing method. So this is this is next, moving on to the charging system. What are the different types of charging? The detailed explanation of the same could be seen in the paper of my research scholar. I've given you the hints, and I will give you the link of my website also, so that you can get the details about the paper over there, and you can have a wider knowledge. So these are the different charging systems which are readily available. One is, it could be inductive or it could be conductive, or the different power levels. Depending on the power levels, it is level 1, level 2, or level 3 charging, and depending on the infrastructure, it could be onboard or offboard charges, or it could be unidirectional or bidirectional charges. So what is inductive? What is inductive and conductive in nature? So you are going to have an hardwired interface. You have the charging station. You have the AC input, or the AC energy is being fed in. AC power is being fed into the system. So AC is converted to DC, and it is being stabilized using a DC-DC converter, and that is charging the battery system. So this is conductive system. What is inductive? There comes your wireless system. So again, wireless is nothing but your inductive thing. It could be again capacitive in nature, or it could be inductive in nature. So that becomes capacitive coupling or your inductive coupling. The same details are there in the same paper. You can just have an overview of that from the paper for further details. Now the next set of charging was onboard and offboard charger. Say I have two different types of charging. I could have AC charging or I could have DC charging. If it is DC, then there is no issues. Directly I could charge the battery. So the problem is solved. I don't need an onboard charger. So I have a DC at the outlet. So DC is directly used for charging. I just wanted a DC-DC converter which is readily available in the DC charging unit itself. So this is DC charging. Whereas when I come to AC charging, the available power is AC. So I have to charge, I have to battery which is DC in nature. So I use the onboard charging unit which converts AC to DC and charges the battery. So again, the next type of charging is level 1, level 2, and level 3. Every electric vehicle, whatever you get now, comes with a free charger, which is residential charger. So it's a small unit, which is just a box-like structure, which could be used in your plug-in houses. You can plug into your socket and you can charge your electric vehicle throughout at night. This is called as slow charging. The rate at which it is charging is going to be very, very less. The amount of current which is taking is going to be 12 amperes from a single phase supply. Okay, so it might take 8 to 12 hours for the whole night. It has to be charged throughout night. So it is going to be an AC, it's charged from AC, and it takes longer time. So this is AC level 1 charger with the residential chargers. Next, same AC level charger 2. Instead of 16, it could be 80 amperes. So it could not be done with your residential sockets. It has to be a special socket which is readily available in the charging station. But this is also, the power is going to be AC. But you can't draw more current over here. It could be to the maximum of 80 amperes. So total about 19.2 kilowatts can be charged. But taking about 8 hours here, it would not be 8 hours, but still the total amount of time duration for charging is going to be from 4 to 5 hours. So this has brought down the usage of electric vehicles. So now we wanted more amount of, with lesser time, you have to charge more. So there came your DC fast charging. So this charges from 60 to 200 amperes. So it just takes 20 minutes or time to just charge it out. And this is fast charge, DC fast charging. So this is the same thing, whatever I've talked about it before. So the same AC, this is level 1 and level 2 charger, where your AC through your electric vehicle support system, it is being connected to your onboard charger through the battery system. If it is direct DC, it is directly connected to the bottom switch. Level 3 charger is nothing but your DC charger. You can just see the electric vehicle system is being added in parallel so that your current is increased. As you all know, basics of electrical engineering, in parallel, the current gets adds up. Okay, voltage remains the same, current gets adds up. So to increase in fast charging, it's going to be 200 amperes. How do we get the 200 amperes? You have parallel systems which are connected so that you drop 200 amperes. So these are the charges which are available, just for your understanding. So there are different types of chargers which are available. SAE is one type of charger. CHAdeMO is, you would have always heard about the CHAdeMO, which is nothing but a Japanese technology of connectors. And next is Tesla uses a supercharger, their own charger. So there are many AC sockets available. So these are the different sockets, which is JSAs, or it could be Meninkus, or it could be Legrand. What is the level of voltage, what is the level of current and power level is being given over here for your understanding. Similar to AC, we have DC also, CHAdeMO, GB/T, or Tesla supercharger. Its corresponding voltage levels, current levels are being given here. So AC and DC chargers are there. This is how it would look like. You will have 3 phase, R by B, neutral, grounding, and 2 things for your protocols, your communication protocols to take place, and all those safety measures also will be there. So these are the different types of CCS, your combined charging system. Combined charging system in the sense it would have AC charging as well as, this is for AC and this is for DC. Okay, when it is DC, it would communication charges from here and your phase and neutral. Sorry, your positive and negative. When it is AC, you have the 3+ over here and your communication system. So this is CCS, combined charging system. CHAdeMO, which is used in Japan, and if it is EU, it is going to be CCS2. China, it is GB/2, and Tesla, it has its own thing. So now coming to India. India, we don't have anything specific now. So people have gone in for CHAdeMO, CCS, and Bharat DC 001, which is specific to India. These are the charging standards which are readily available. This is the look of DC charging station. As I told you, DC charging station means the solar is being brought into picture. See, having brought in electric vehicle, if you are still depending on to the grid, and if you are going to load the grid system, then it is going to be totally no use. So hence renewables has to be brought in. So this is a DC charging unit with your solar system. These are some of the glimpses from Indian DC charging station, which is super fast EV charging station at Pune by NG Motors, and this is by Delta Electronics. This is AC charging units, and this is the charging unit by Navi, which is placed at Navi Mumbai, and this is by Tata. These are the different electric vehicles, which is not necessarily being a car. It could be a 2-wheeler, it could be a truck, it could be the total electric ship, Stena line, or it could be bus or the metro systems. So these are some of the works which I have carried out with my students. Regarding with wireless technology, we have just gone in for finding out the best resonant power electronic system which can work out for the wireless system. And you can see the details of that in the 2 papers that are being listed here. The other work which was carried out was vehicle to vehicle transfer. See, this is like your system might have SOC problem, and if the charging station is nowhere nearby, you might have the last mile connectivity issues. So then there must be a technology where vehicle to vehicle. Just imagine the world with only electric vehicle. In that particular scenario, there must be some vehicle to vehicle transfer of energy which is possible just for emergency condition, just for last mile connectivity. So that particular detail could be taken up from this paper. This is a work with one of my MTech students for last mile connectivity, vehicle to vehicle charging, V2V. Normally, the one thing which is very much famous in electric vehicle is V2X. It could be vehicle to home, it could be vehicle to vehicle, vehicle to grid, grid to vehicle, etc. So in future, electric vehicles are being seen as one of the storing unit itself. So having thought about electric vehicles, all these petrol bunks has to be replaced with electric vehicle. Where and how to place the electric vehicle is going to be a question mark. So now this is one of the work where we have done for placing the electric vehicle, where exactly an electric vehicle has to be placed with our optimization technique problems. So that details could be got out from this particular paper. And we continued the work with the swapping also. The next technology which is going to take it up is the battery, since SOC problem is there and charging infrastructure problems are there, especially in India. Charging infrastructure has to be increased a lot. When we are thinking about to change 70% of the vehicles totally into electric, then charging infrastructure has to be brought in, which are under construction now. So battery swapping stations would be a main use. So this is one of the things where to give the swapping station, where to have the charging station. So this is an optimized technique which is being used for placing out, for giving an idea for placing out what should be the charging station and what should be the number of swapping station in an area for real time. This is the next work which we have carried out with one of my MTech student, which is for vehicle to grid and grid to vehicle energy transfer. Okay, so we definitely will have power quality issues. So, and we have brought in our machine language and fuzzy logic into picture for sharing the energy from the electric vehicle to the grid or to the residential area thing during the peak load conditions. So this is the extension of the same work. This is one of my PhD scholars' work, just giving an outline of the different charging unit, its communication protocols, etc. We have something called as coordinated and uncoordinated charging. So the effect of those things and which has to be performed, why, and etc. is going to be found in this particular work. Since I'm running out of time, I'm just scrolling out. You can just refer to the papers to get more details. And this is the work of my PhD scholar in battery management system. So we have worked out with the different modeling which are available. Electric battery, as an electrical engineer, we would be finding out just electrical equivalent. So we have 3 RC model, 1 RC model, 4 RC model, etc. For electric vehicle, 3 RC model is more than sufficient. We have done some hardware work in that battery management system, and we have gone in for passive a technology with machine learning introduced for passive balancing, etc. And those works are being noted down here. We have some 7 papers, journal papers over there. You can readily refer to it for different technologies which are being there, different active balancing technique and the machine learning, what concept we have introduced also. So moving on to the last part of it. India has focused itself towards the research in electric vehicle, and the main aim of India is to bring in 70% of electric vehicles from two-wheeler towards the heavy bread truck to be changed as electric. So it has started in 2011 as National Mission Policy, and now it has reached FAME. FAME is nothing but faster adoption and manufacturing of electric vehicles. Many subsidies have been given for these particular things, so that it helps green corridor system, whatever is being introduced by India. So this is just a glimpse of what is FAME, etc. Okay, the main idea is target is to bring in 6 to 7 million hybrid electric vehicles by 2020, which is most probably 80% successful also. So this is the main aim of FAME. And the rough amount figure you can see over here, minimum it is 51 lakhs and the maximum it is 73 lakhs of personal vehicles are being the target which has to be reached in 2026. So this is the study which has been done by Indian government, at GDP rate of 5.8. So there are many units which are introducing their charging systems, which is NTPC is there, Bharat Heavy Electric, or EESL, Energy Efficient Services, Rajasthan Electronics, Tata Power, Mahindra, Fordham, Lithium Urban, which are into charging business, and they are trying to put up charging stations all throughout India and each and every corner. So these are the glimpse of charging stations. So what would be the challenges? Charging infrastructure is going to be the biggest challenge. Our government is trying to put up a charging station on highways for every 10 kilometers. But of course, it would take some time over there. And next is battery performance. The number of cycles, what it's going to affect. It's going to be a closed loop. After the 200 cycles, the battery has to be replaced. The particular battery can be reused in a lesser areas. In some other areas where of same voltage, this can be reused there. Okay, and after that it could be recycled and it has to come back. So this is recycling and all those things would be a major issue, and the cost of it is the next thing. So this is the same thing. This is the model, business model, which is to be developed. So these are some of the examples of electric cars readily available in India. Thank you. So I've just tried to give you a glimpse of it. I guess I have.
Thank you, ma'am. So, ma'am, can we go ahead and take some time for questions?
Yes, sure, Lakshmi.
So, the meet is open for sharing. Please don't hesitate and feel free to clear your doubts. If any questions, please either type it in your
Hello.
chat box or
Hello. Can I ask a question?
Yes, Srihari, go ahead.
I would like to know, as a future electrical engineer, how we can prepare ourselves to during this BTech program to work in the electric vehicle industry in future.
Yes. So Srihari, I guess you would definitely have a subject which is power electronics. Okay. Yes, right? Yeah. So that particular power electronics would come into your battery. See, you again in electric vehicle, you can choose your area. So I always advise the student to just stick on to their area which they are comfortable or their field of interest is. Suppose if you are good at power electronics, then you can choose the areas where it is battery management systems and cell balancing, etc. Okay, that particular part of it, you can just to be thorough the power electronics, and you can just take up a project in battery management system or active cell balancing or DC converters or the inverter technology for controlling this thing and do a small uh, simulation
Ma'am,
works
we could not
over
hear
here,
clearly what you're saying.
and then take up a small internship in any startup. There are many startups in electric vehicles which are giving internship. So those two would have a good hand in hand helping each other for you for the near future to go out take up an electric vehicle job. And if I would just suggest you to just take up electronics, but again, a drive system, you have many modems which are associated with controlling the speed or the torque of the motor. Different lane, you can take it up. Or battery chemistry over there, and you can take that in a different of it, which is going to be the main heart of the autonomous system, which is going to be the near future. See, it is not going to be the future is not only going. This roadmap is just going to end in autonomous vehicle. Then just take up the control techniques or the CAN protocols, etc., which are controlling the vehicle from to autonomous thing. So this we take up a small work of an idea. Am I not audible? Hello, Srihari?
Yes, ma'am, you're audible.
Hello, Lakshmi, am I audible?
Yes, ma'am, you are audible.
Yeah, yeah. So, was that question were you able to hear, or should I repeat it? Answer?
It was not much clear, ma'am.
Okay, so it depends on to the stream what you are familiar with. If you are a power electronic, if you are interested in power electronics, then you might work out a small works. You can take up a small work in DC converters or inverters, a small simulation, and then take up a small internship in any startup so that it goes hand in hand. Or if you are very good in machines, then I would request you to stick on to machines itself with the drives part of it. You can concentrate onto the drives. You have many control techniques in drives coming into picture. You have Kalman's filtering technique or DTC, etc. So you can concentrate onto the drives part of it in machines. Or if you're good at battery chemistry part of it, you can stick on to battery chemistry. The other one would be the controller part of it. The future roadmap of electric vehicle is going to be autonomous vehicles. So if you're very good in microcontroller programming or anything, then you can take up the controlling part of it or IoT related stuffs in electric vehicle, do a small work, and then do some internship in that. Maybe that could control both your motoring thing, driving part, or your BMS thing, etc. And then you can move into your autonomous vehicle. So that would be the way in which any electrical engineer can move in.
Okay, ma'am. Thank you.
Any other questions? Please feel free to ask.
So I guess I've not taken much of your time. Srihari, thank you so much again, once again, for having contacted IEEE Student Activities Committee of Virtual Speakers Bureau. And special thanks to Salin sir also.
So we could, with that, I think we could wind up the session. So now I would like to welcome Sri Hari, our to give the vote of thanks. Sri Hari, please.
Yeah, thank you, Lakshmi. I think it was a wonderful session on electric vehicles. I must say I learned many things, and as a future electrical engineer, I think it will be a milestone, maybe in my career too, because now I know many things the electric vehicles that I did know in past. And I would like to thank Honorable Deepa ma'am, who had joined us today to deliver the speech, uh, the lecture on this topic. And I am already in receipt of many messages saying that it was a very useful session. And I would like to thank her on behalf of our IEEE PSSBC and also on behalf of our college and also the participants. I on representation of the participants who are assembled here. Thank you, ma'am. And I would like to also thank our honorable advisor Sri Salin sir and also the participants who are gathered here. Thank you.
Thank you, Srihari.
Thank
Once again, thank you, Deepa ma'am, for your consideration and joining us even in this pandemic situation. Thank you,
thank you,
Salin sir, and
Lakshmi.
thank
Thank
you.
you, Hari. Thank you, Salan sir.
Thank you, ma'am. Thank you, Salin sir, and thank you all for your cordial cooperation. Thank you.